Hello, Dean, KK4DAS here. Welcome to another update on the SolderSmoke Direct Conversion Receiver Challenge. This is a bonus video, just a short video. We're going to talk about soldering Manhattan style. So let's take a look. First, let's talk about the soldering station. You need a temperature-controlled soldering iron around 735 degrees Fahrenheit. You need a chisel tip. You need a nice wide chisel tip because you're going to want to transfer maximum heat to the pads and to the board. You want a wet sponge to keep the iron clean, and a brass sponge also to keep it clean. Those two things help keep the iron clean and assure maximum transfer of heat. Pair of needle nose pliers for bending leads, some snips for cutting them, trimming them to edge. Important is hemostat for holding small parts, and unless you have heat-resistant fingers, which I do not. Very important also is a fan to blow away the smoke, so you don't want that solder smoke drifting up into your face. We recommend using leaded solder, 6040 leaded solder. I like the Kester solder. I find that the unleaded solder doesn't flow well and is much harder to work with, so I prefer using the leaded solder. Another thing that I have on the board there is some helping hands. It's always good to have something to hold the parts with while you're soldering. So those are the kind of key parts of the soldering station. When you're done, the board should look something like this. You want nice shiny pads where the solder has flowed. You don't want globs of solder sitting like a ball on top of the PCB, and you want the leads to be mostly covered with solder. You don't want leads just kind of sitting on top of the pad and lightly tacked. You want them covered and adhered to the solder. You're trying to make a bond between the board and the lead, and so the tighter that is, the better. Cold solder joints are one of the banes of homebrew soldering and homebrew projects. So with that, let's dive in and take a look at how we get there. I have my soldering station set up here, and I want to point out a couple of things. One is I always keep a bottle of water close so that I can keep the sponge saturated. That's important because you need a very clean tip in order for heat to transfer properly. I also have this brass sponge there that can be used to clean the tip, and I have the temperature on the iron set to about 735 to 750 degrees. I'm using leaded solder, 6040 Kester leaded solder. I have my helping hands here, and I have my tools all handy and ready to go. So, first thing you need to do when you're soldering to a Manhattan board is get some solder down on the pads on the board. And we're going to just start by putting this little 100 ohm resistor on the board and just show you what that looks like. So first thing I do, I guess one thing to point out is I have a chisel tip, kind of a medium-sized chisel tip. You want a chisel because you want to be able to transfer maximum heat to the board with the flat end of the chisel. So I always clean the tip first, so it's nice and clean. Then I put a little bit of solder on it, and that tends the tip. Then I'm going to put the iron down on the pad, let it get hot, and put the solder on the pad as well, and let a nice pool of solder flow to the pad. And that's what it should look like. Now I can do the same thing on the ground plane. Now the ground plane may take a little longer to warm up because it's a bigger piece of copper, but the same thing happens there. And you see that the solder just starts to flow, and you get a nice little pool of solder, and those become your two connection points. Now, what I like to do for the resistors, save space on the board, is I like to bend over one of the leads like that, and then just make a little 90 degree, and then one side should be just slightly shorter than the other because you're coming off of the pad. So it looks like that. Then I trim off the ends. You don't need a whole lot of lead on there. In fact, sometimes the shorter the better. And that's just going to get glued down or soldered down right like that. But before I do that, I'm going to tin the leads on the resistor. So use my helping hands. Got my solder, got my iron. Always clean the iron before I start. A little bit of solder on the tip of the iron, and then just get a little bit of solder on each of the leads. And when you do that, you will find that it goes down on the board much easier. Now that's going to be hot, so be careful when you take it out of your clamp. It cools off pretty quick, but it's also very hot to begin with. Now, once you have the leads bent and trimmed and tinned, then clamp it in the hemostat so you don't burn your fingers. Just hold it. You don't need to put pressure. Just hold it gently down on the pad and apply the iron to the junction of the pad and the lead until the solder flows. Then remove the iron, give it a count of 1, 2, 3, and you're done. And then same thing for the ground lead. Apply the iron to the junction of the part. Watch the solder flow. The solder should flow, and you're done. You should have nice little pools of solder. The lead should be pretty much completely covered up. If you tug on it a little bit, it's not going to come off. You don't have clumps of solder all over the board. And that's how you solder a component to a Manhattan pad PCB. Now I'm going to set up for a transistor and kind of show you some hints and tricks for soldering in a three-legged device. I'm going to solder in this 2N3904 transistor, and I know a 2N3904 has 3 terminals, and from the flat side forward, from left to right, you've got the emitter, the base, and the collector. Emitter, base, collector. And I know that from looking at the data sheet or from testing it with my little tester that I demonstrated in the previous video. So those are the 3 leads. I like starting with the pads for the transistors glued down, ready to go, and I've marked where the base, the emitter, and the collector go. You don't have to mark them, but I did that just for the kind of demonstration purposes so we can see where they go. What I like to do with the transistor is bend the legs so that they make kind of a little 3-legged stool. And so I'll take the collector and give it one 90 degree, a second 90 degree, and then a third 90 degree. And then I'll do the same with the base, and I know the base has got to go back, so I'm going to kind of start at about the same place. I'll actually do the emitter first, get that out of the way. So we'll do the emitter. 1. You don't have to be super precise about this, but you get the idea. You're making a little stool, basically. Okay, and now for the base. All right, so now I've got my little 3-legged stool, and you'll see that when I put it down, it'll go right on the pads there. So that's basically what you want. And you can adjust a little bit. You can tighten the leads up a little bit so they're not quite so far apart. but you basically adjust it until it's going to go pretty much where you want it to go. If you've done it right, it'll just stand up there. Okay, so there we go. So now I'm going to do just what I did before. I'm going to tin the pads, I'm going to tin the leads, and then I'm going to put the transistor down. Okay, I've got solder down on the pads, the leads are tinned. Now, a good habit to get into when you're soldering is to clean the tip before each time you solder. So I go 1, 2, 1, 2, and then I've got a nice clean tip. So I'm going to just put the base pad down, and just like before, I'm just going to touch it, watch the solder flow, remove the iron. Okay, now you see I didn't wait long enough, so I got to wait till it solidifies. 1, 2, 3, 4, 5. Okay. Now I can gently adjust where the other leads are going to go. And sometimes just holding it with the needle nose will make a difference. You want to make sure that it's actually touching the pad when you apply the heat. 1, 2, 3, there we go. Yep. Okay. And then the last lead. Lift that foot over, make sure it's got a place to land. There we go. And you can see when you have the leads properly tinned and the pad tinned, it does not take much. So there you go. That's Manhattan style component soldering.